Hello students, let us continue the session on triangles. In the previous session, we have discussed about some criteria for similarity of triangle. Let us learn another very important concept called as basic proportionality concept. Before doing that, I'll be explaining few properties of triangle which we had learned in class 9th, which will be used in proving the basic proportionality theorem. Look at this. There's a road. On the sides of the road, there are street lights. On the poles of these street lights, if you imagine a triangle, by joining the bases, we get two triangles here. Look at these two triangles. Can you observe anything common between them? These two lines which are there here, they are the parallel lines. They run parallel. Between these two parallel lines, for these two triangles, if I name this triangle as ABC and this vertex as D, ABC and BDC, they are the triangles. For these two triangles, you can observe there are two things which are common. They are the height and the base. BC is the base and the height between the two parallel lines are always same. So the height for both the triangles, triangle ABC as well as the triangle BCD, will be same. We have learned in lower classes that area of the triangle is half base into height. Here the base into height. If we do that, we get the area of the triangles. For the triangle ABC, the area is half into BC into height. If I consider this as H, so area of triangle DBC will be half into again BC into height. You look at these two right hand sides, you can say that the left hand sides are equal. Area of triangle ABC will be equal to area of triangle DBC. So this property is whenever two lines are parallel to each other, between them if you draw two triangles having the common base, their areas are equal. In other words, I can say that area of triangles on same base between same parallels are equal. This property we have learned in our class 9th, which we will be using in class 10th too. I want you to observe another situation. There are 4 street lights. In this situation, I'll take one of the street light to another side. So only one street light is there towards the top and 3 street lights are at the bottom. Now if you join the bases, we get 2 triangles. For these 2 triangles, the height remains the same. If I name this vertex as A, this as B, C and D, now the larger triangle ABD is split into triangle ABC and triangle ACD. For both triangle ABC and triangle ACD, height remains same. Observe these bases. Bases are different, only the heights are same. If you consider area of triangle ABC, it is half into base BC into, if you consider the height as h. So the area of triangle ACD, if you take, it is half into CD into h. Let me call this as equation 1 and this as equation 2. What if you do equation 1 divided by equation 2? We get area of triangle ABC upon area of triangle ACD. This will be equal to half into BC into H divided by half into CD into H. Half will get cancelled, H also will get cancelled. We will be getting only BC upon CD. So whenever two triangles are having different bases but they are lying between two parallel lines in this way, the ratio of the area of triangle will be equal to ratio of their bases. This property also we are going to use it in a very important concept called as basic proportionality theorem. Let's see what is that basic proportionality theorem is all about. Basic proportionality theorem, or sometimes they mention it as BPT, states that if the line is drawn parallel to a side of a triangle to intersect the other two sides at distinct points, then the other two sides are divided in the same ratio. If I consider triangle ABC, if a line is drawn parallel to the side BC, to this side, if one more line is drawn parallel, it intersects the other two sides at distinct points, which makes the sides divided in the same ratio. Means the side AD by DB will be equal to the side AE by EC. This we are going to prove. What is given in this? Given is in triangle ABC, we have the line DE parallel to the line BC. What is to be proved? We need to prove that the ratio AD by DB equal to AE by EC. How we are going to do it? I'll do in 2 steps or 3 steps. The first step which I am going to consider is, I will consider the triangles such that there is the two sides considered. For doing that, I will join BE. So we have joined BE. Now you can observe there are two triangles here. This is one triangle. This is the other triangle. In the second property we have seen, whenever two triangles are formed from a triangle, then the ratio of their areas, that is area of triangle ADE upon area of triangle BDE will be equal to the ratio of the bases AD upon DB. Correct? Same way, let us do one more construction. One more construction is, we are going to join this DC. Upon joining DC, we get two triangles. Now I'll consider the area of triangle ADE by area of triangle DEC. This will be equal to ratio of the bases AE upon EC. We have learnt in the first property that the triangles having the common base between the parallel lines are equal. So the area of triangle DEC will be equal to area of triangle BDE, since triangles on same base between same parallels are equal. Observe the left hand side and the right hand side. Since DEC is equal to BDE and the numerators are same ADE, the right hand sides will be equal. So on comparison, let me write it here. On comparison, we get the ratio AD upon DB equal to the ratio AE upon EC. Hence proved. This theorem is called as a basic proportionality theorem. Now once again I want you to recall, we have the triangle ABC and we have drawn a line parallel to the side BC. It intersects at two distinct points D and E, and the result obtained is AD upon DB equal to AE upon EC. Let's do +1 on both the sides. We get AD plus DB upon DB equal to AE plus EC upon EC. What is the sum of AD plus DB? We have AB. AB by DB equal to the sum of AE plus EC is AC upon EC. This is one more result obtained from the basic proportionality theorem. This one, the new result obtained is a corollary. We can also consider the reciprocal of this. We get DB upon AB equal to EC upon AC. Let me call this as a corollary 1. This one is corollary 2. In the corollary 2, we got the result as dB upon AB equal to EC upon AC. Suppose if I subtract from 1 both the sides, what is that we are going to get? We get AB minus DB upon AB equal to AC minus EC upon AC. What is AB minus DB? Look at the figure here. AB minus DB will be AD upon AB, which is equal to AC minus EC. AC minus EC will be AE upon AC. This is the new result obtained. I'll call this as corollary 3. We can take the reciprocal of it. We get a new result. AB upon AD will be equal to AC upon AE. This I'll call this as corollary 4. So we have discussed an important concept called as basic proportionality theorem in a triangle, say XYZ. If you draw a line parallel such that the other two sides are intersected at distinct points, then the ratio XP upon PY will be equal to XQ upon QZ. And we have seen the corollary. This will be XP upon, I can say, XY will be equal to XQ upon XZ. This was our corollary 4. I'll name this as 1, 2, 3, 4, so on. The second result obtained will be, say, XY upon XP equal to XZ upon XQ. I have just taken the reciprocal. The third result is PY upon XY equal to QZ upon XZ. And the fourth result obtained is a reciprocal XY upon PY equal to XZ upon QZ. We are going to use this result of corollary and the basic proportionality theorem in solving the questions. In the next session, we shall solve few questions related to basic proportionality theorem. And also we will see the converse of basic proportionality theorem. That is, if we have the ratio of the two sides divided by a line are equal, then the line will be parallel to the third side. We are going to learn the converse of basic proportionality theorem in the next session. That's all for today's session. Thank you.